In this video, we are going to look at conservation of heat problems. So these will be two-step problems where you'll be using the specific heat equation 2 times. So in this first step, we will need to find the heat energy of the water. So we're going to start out the same way as we always do with these specific heat problems by identifying all 4 variables that we have. In this word problem, you are going to notice that there will be variables or numbers that relate to water, and then there will be variables or numbers given that relate to the metal. In this first step, we're just looking at the ones that apply to water. So we're going to look for mass of water. Mass of water is 50 grams. So I'm going to label that here. I'm told that the water is initially at 20 degrees Celsius. I keep reading. I'm told that I have 31 grams of an unknown substance. That substance is not water, so I don't need to worry about that number yet. I'm told that this unknown substance is at 100 degrees Celsius. Again, that doesn't apply to this first part of the problem because I'm just picking out variables that apply to water. I am told that the final temperature of everything is 25 degrees Celsius, so that includes both the water and the unknown substance will have that final temperature. So I'm going to use this as my final temperature. The 20 degrees Celsius was the initial temperature of water. So take the difference between those two. Difference is 5 degrees Celsius. The other thing that I'm told or given in this problem is that the specific heat of the water is 4.186 joules divided by grams times degrees Celsius. So I'm first going to find the heat energy. So E is my unknown. I'm going to use the equation E is equal to mc times delta T, change in temperature. So I'll plug in all 3 numbers that I'm given, 50 times 4.186 times 5, and I get 1046.5 joules. So that is step number 1, finding the heat energy of the water. Step number 2, I will need to use the heat energy from step number 1 in order to find the unknown or the mystery specific heat. So I'm going to start out the same way by identifying all 4 variables. Energy, that's the number that I got in step number 1, so 1046.5 joules. Then I need to read through the problem to find my other variables. This time I'm only using the variables that apply to the unknown or the mystery sample. So I'm told that I have 31 grams of my unknown substance. Mass is measured in grams, so I have 31 grams. I'm told that this substance has an initial temperature of 100 degrees Celsius and the final temperature of everything, meaning both the metal and the water, is 25 degrees Celsius. So I'm going to take 100 minus 25. So C, specific heat, is my unknown. So I'm going to use the equation C is equal to E divided by M times change in temperature. I've just rearranged the equation E is equal to mc times delta T to solve for C, specific heat. So I have 1046.5 in the numerator divided by 31 times 75. Remember to put these 2 numbers in the denominator in parentheses when you multiply them. You'll end up getting C is equal to 0.449 joules divided by grams times degrees Celsius. So in this problem, we're asked to find the unknown metal. So we're going to have one last step on this problem where we use the specific heat value that we obtained. So we got C is equal to 0.449 joules divided by grams times degrees Celsius. So we're going to be using this mystery specific heat to find the identity of our mystery metal. So we're going to look for the substance that matches this specific heat. So we'll see that that substance is iron. So our unknown or mystery metal is iron. This entire problem works because of the conservation of heat, which tells you that in these problems, the heat energy that will be gained by the water is equal to the heat energy lost by the metal. So if you put a hot piece of metal in water, there's going to be energy that's transferred to the water. It's going to heat up the water and the metal will lose heat. So that's the whole premise of this type of problem. We're going to try one more example. If you feel confident, pause the video, try it on your own, and then you can listen to the explanation. So again, step number 1, we're going to find the heat energy of the water. So I'll identify 4 variables. When we're reading through this problem, we are only going to pick out the variables that apply to water to begin with. So we have 12.6 grams of zinc. That's not water. Don't worry about that yet. This zinc, this piece of zinc, is heated to 99.5 degrees Celsius. Don't need to worry about that yet. We're told that this piece of zinc is added to a beaker containing 50 grams of water. So that is our mass of water. You're told that this water is initially at 23 degrees Celsius. Keep reading. You're told that the final temperature of both the water and the metal is 25.8. So we're going to find the change in temperature. Our specific heat value for water is 4.186 joules divided by grams times degrees Celsius, and then heat energy is unknown. Use the equation E is equal to mc times delta T. So 50 times 4.186 times 2.8, and that gives you an energy value of 3,511 joules. So there's step number 1. Now in step number 2, we are just going to use the values related to the metal. So because of conservation of energy or conservation of heat, we can use the energy that we found in step number 1. And then we need to go back through our problem and pick out the other pieces of information that we know. So we have a 12.6 gram piece of zinc. That's our mass. Because in step 2, we're only worrying about the variables that apply to the metal. Our specific heat, that's what we're going to be trying to find in this part of the problem. And then change in temperature, we know that the initial temperature of the piece of zinc is 99.5, and then the final temperature of everything, that's what it means to come to thermal equilibrium. That means the temperature of both the water and the metal is the same, and that temperature is 25.8. So our change in temperature here is 73.7 degrees Celsius. And so now we are using the equation C is equal to E divided by M times change in temperature. So we end up getting 0.901, and then units for specific heat are joules divided by grams times degrees Celsius.